Welcome back to our series on chemistry. In this section, we're going to begin to talk about atomic bonding. Remember, atoms usually don't occur alone, but exist with other atoms. In fact, if we were looking at the periodic table right now, hopefully you can remember the far right-hand side had the noble gases. Those are the kinds of atoms that like to exist by themselves because their valence shell is full. Almost every other atom on the periodic table likes to bond with others of its own kind or other elements that are on the periodic table. We give these different groupings names. An element is going to be a pure substance. It means if you looked at the periodic table and picked any block, it would be more than one of that atom together. Substances. Substances are when you choose two or more items from the periodic table that are going to bond together. Two examples of that would be H2O, or water, and NaCl, or table salt. Then you have an item called a molecule. A molecule is when two or more of the same atom bond together. Examples of that are nitrogen and oxygen. An example where there's more than two together would be ozone, or O3. Now, sometimes atoms don't actually bond together, but they're in the same place together, and these are going to be called mixtures. They combine physically, but generally not chemically. Here's a little bit more about compounds. Eventually, we're going to talk more about what's going on with the yellow electron that you see over here. But what I'd like you to know is that there is an actual physical change that happens between two atoms when they're going to bond. So for example, here you can see how this one electron from sodium is coming to be with the chlorine. Because the charges are different, positive and negative, the items are going to be attracted to one another. Here is a picture of the difference between molecules and compounds. Can you see how everything on the top row is a pair, the same, paired with the same? These are all molecules. At the bottom, we have one or more different atoms coming together. Here you have nitrogen and oxygen, which makes nitrogen oxide. When you have nitrogen with two oxygens, that's going to be nitrogen dioxide. Two or more of the same, two or more different. You might be wondering why it is that atoms bond at all. This is because they want to be stable. And to be stable, they need to have a complete outer shell. Generally, a complete outer shell contains 8 valence electrons, but there's a little sneaky guy in there called hydrogen, and he actually only needs 2 because he only has a single valence shell, or a single shell, and it is his valence shell. If you remember back a little ways, the innermost shell can only hold 2 electrons, which is why hydrogen fills at 2. When they work to fill their valence shells, they're either going to give away or share or receive an electron from another atom. Keep this in mind. The atom is smiling when its outer orbital is full. Sometimes this means it will lose an electron or 2 or 3, and sometimes it means it will gain an electron 2 or 3, or it will share 1, 2, or 3 electrons. Remember, atoms need to bond together to make molecules and compounds. Again, a molecule is a singular grouping, 2 of the same atoms together, 3 of the same atoms together. A compound is composed of atoms of different elements. It can be 2 or 3 or 4. Here's a great example of a compound right down here at the bottom, C6H12O6. This is actually sugar or glucose, and it's one that you're going to see through a lot of future chapters. It's one of the reasons that we're doing bonding is so that when we get to some of these more complex biology topics, you're able to understand the chemistry that goes to support the biology. There are three types of bonds: ionic, covalent, and hydrogen. For right now, we're going to focus on ionic and covalent bonding because hydrogen is a special type of bonding. And we're going to end up dealing with that in the next section when we really look at a particular compound that bonds through hydrogen bonding. Let's go back to ionic. Ionic, one atom, which is unstable, gives away 1, 2, or 3 electrons. Another atom, also unstable, accepts those 1, 2, or 3 atoms. When this happens, the giving molecule has 8 on its outer shell, and the receiving molecule has 8 on its outer shell. They then become bonded together because the charges on the two atoms will be different. Covalent. Covalent is a sharing bond. It means that two atoms of a similar size are going to share 1, 2, or 3 atoms. These are called single, double, and triple covalent bonds. These are really strong bonds. For example, in the air around you, there's nitrogen. That nitrogen is actually a triple covalent bonded pair of nitrogen atoms. If you want to naturally separate those atoms, you have to do something like strike it with a bolt of lightning for that to happen. These bonds are incredibly, incredibly hard to break. Here's an example of a covalent bond. Notice, this is fluorine. It has 1, 2, 3, 4, 5, 6, 7 outer electrons. This is a second fluorine. It also has the same amount of valence electrons. Now think, do you think this fluorine could steal electrons from this fluorine? Probably not, because they both want the same number of electrons. They both need an additional 1. And since both the fluorines are the same size, they end up sharing. They share 1 pair, and thus they both have 8 part-time. Down here at the bottom, here's a little tiny hydrogen and a much larger oxygen. So you may wonder, well, why doesn't the oxygen just bully the hydrogen? Why doesn't it just steal that 1 electron? Well, to do that actually requires a tremendous amount of energy because this is hydrogen's only electron, and hydrogen's nucleus holds onto that electron really jealously. So instead of oxygen stealing it and leaving just a free-floating proton, they form covalent bonding. We're going to talk about what kind of very specific covalent bonding this is in the next section. Examples of ionic bonding: NaCl. Do you see how, now we're finally looking at the whole atom. We're going to look at the inner as well as the valence shell. Look at what happens when this electron goes away. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons end up being left, and the sodium becomes positively charged. See this little empty spot? Chlorine has 7 valence electrons. When it takes this electron from sodium, it then has 8 valence. So this one has 8 on its valence shell. This one has 8 on its valence shell. This one is positive. This one is negative. So opposites attract and they come together. There are lots of examples of this. I put this one in specifically because I wanted you to see. Remember, the inner valence shell only has 2 electrons. So if an atom only has 2 shells and it loses the electron off its valence shell, it is just as happy at 2 as the chlorine is at 8, because remember, 2 is filled for that inner shell. I didn't want you to think that this could only happen with one atom to one atom. So here's another example. Calcium. Calcium has 2 valence electrons. Chlorine each only need 1. So if you are going to make calcium chloride with only 1 chlorine, calcium would still have this leftover electron here. So that's why calcium chloride isn't CaCl. It's CaCl2. So that when we look at the outcome, everybody has 8 valence electrons. Calcium is positive by 2 because it lost 2 valence electrons, and chlorine is negative by 1 Because it gained them. So we have the ion Ca2+, the ion Cl1-, but not just one Cl1-, we have two Cl1-. These are the kinds of questions that you should be able to answer. We're going to get back together and study this topic some more.